We are now ready to take on 3 variable systems of equations as opposed to 2 variables. Right now we're learning to work them by hand, which at the moment our primary method is going to be using elimination. Now in the next chapter we will also work with 3 variable and larger systems of equations, but that will be when we are able to apply matrix operations, which can make this more effective. For us right now to do it by hand, elimination is our primary choice. Doing these by substitution is pretty challenging. Okay, if you've learned to do this before, there's a general process. You have to work your way down. First, we have to get rid of one of the variables. You have to decide, do I want to eliminate x's, y's, or z's? It absolutely does not matter at all how you choose to do it. Just for the ease of following what I'm doing, I'm going to opt to get rid of x's first. So our first thing is you can only do 2 equations at a time. So you need to pick 2 equations to eliminate, in this case, the x's. So if I'm going to do that, I'm going to opt to do these first 2. They're nice conveniently. What do I have to do to eliminate the x's? Well, I need to multiply the top equation by -3. The bottom one looks like it's fine. So we're eliminating x in equations 1 and 2. I'm going to then multiply my -3x through there, which will give me 45 at the end. And then the second equation is fine. It's got the positive 3x. I'm just copying it down. Key thing is, make sure you keep stuff lined up. You write neat enough. The last thing you want to do is make tiny mistakes on this. You also want to make sure that you did indeed copy the problem right. That's really painful if you don't. Okay, we're now adding them together. And so the x's cancel. I'm left with -11y plus 13z equals 83. That's equation number 1. Now, you may or may not remember this. When you go to do it again, okay, I would like to eliminate a y or a z now, but I can't eliminate y and z because I don't have a second equation. So you must go back. Your second step, you must go back and eliminate the same variable again. So in step 2 here, we are going to eliminate x in a different pair of equations. Key thing, must be a different pair. In this case, I'm going to do equations 1 and 3 this time, since that looks pretty easy. So if I'm going to put 1 and 3 together, I'm looking at this going, okay, what do I need to do to eliminate the x's using 1 and 3? Well, this time, I know I need, if I'm going to do that, I'm going to need to multiply the top equation by -2. So I'm taking the top equation times -2, which would give me -2x, -4y, positive 8z, and a positive 30. I'm going to leave the third equation alone and just copy it down. And once again, my x's should eliminate. My y's I will get 3y plus 3z equals -3. Wow, that's a lot of 3's. Okay, now does anyone remember what you do once you've reached this point? Well, the strategy is the fact that you now have 2 equations that both contain y's and z's. So your third step is to combine the two variable equations and eliminate a variable. So I'm actually going to rewrite these together here. I have negative 11y plus 13z equals 83. And I have 3y plus 3z equals negative 3. Okay, none of these is looking like great numbers, which you think would be easier to get rid of, the y's or the z's. It's about the same. However, I notice the y's have opposite signs, so yeah, I think I'll go with the y's. But if I'm going to do the y's, what number is in common to negative 11 and positive 33, or excuse me, positive 3? Yes, I'm going to have to make them become 33. So I'm going to take the top one times 3. I'm going to take the bottom one times 11. I want them to stay one positive and one negative. So if I do that, I now have negative 33y, positive 39z equals 249. And then positive 33y, positive 33z equals negative 33. My 33y's cancel. And now the moment of truth arrives. If I add that down, I've got 72z. And 249 minus 33 is going to be 216. And this is where you find out if you did it right or not. Because you hope, when you go to solve for z in this case, you hope that it's divisible by a decent number, or at least a simple fraction that's nice. And in this case, it does indeed come out to z equals 3. So at long last, I have now figured out that variable z is 3. Problem is, I need to also find x and y. Does anybody remember how you do that? Well, sure. Once you have one variable figured out, you can now go back. I'm going over this way now. Step 4. You're going to sub the value you just found into a 2-variable equation and solve for the remaining variable. Okay, so looking at the 2-variable equations, I know z, I need to solve for y. I think I'm picking the one with all the 3's in it. So I'm going to opt to go 3y plus 3. In this case, z, we found out, is 3. And that's supposed to equal negative 3. So 3y plus 9 equals negative 3. That gives me 3y equals negative 12. And I'm down to y equals negative 4. So now I have gotten 2 variables solved for. I have the solution for z. I have the solution for y. And long last, how do I get the solution for x? Well, of course, I have to go back to one of the 3-variable equations. So our final step then is to sub both of the values we found so far into one of the original equations. Sorry, these are going to be very lengthy notes to look at. But pick one of the equations up there. I need to solve for x. The first one is a 1x, so I'm going to recopy it here so you can see it. But yes, I'm taking the top equation. I'm going to sub in the fact that I know y now is negative 4. And I know that z is positive 3, and that is supposed to equal negative 15. So at long last, that's x minus 8 minus 12 equals negative 15. That's really 20, so if I add 20 to the other side, I'm going to come up with x equals 5. And I have reached my solution. Once again, since our answer is an ordered triple, you solve for 3 variables. You need to write your answer in the form x, y, z. And so we would go, in this case, x is 5, y is negative 4, and z is 3. And we have found our final solution. So, not that hard to process, just a little time consuming. If you make a mistake, it's a pain to find your error. No doubt about it. Okay. The only other thing you're going to do in this assignment today is, yes, some more fun and exciting word problems. Can you take and translate the words into, in this case, three variable equations? If we're solving for 3 variables, we have to have 3 equations. So from this information you see here, we're going to have to derive 3 equations. I wish this was true, but somehow I don't see a local bank doing this, but it's entertaining. The local bank invites its customers to view a large sack full of $5, $10, and $20 gold pieces, promising they'll give the sack to the first person able to state the number of coins for each denomination. And they're given the following information. There are exactly 250 coins in the sack. The total value is $1,875. They're also told if there are also 7 times as many $5 gold pieces as $20 gold pieces, how many of each denomination are in the sack? Okay. What's the first thing you should do? And yes, that's define your variables. Once again, when you fail to do this, you fail to understand your problem. So, most of you the other day, I was seeing you write x equals $5. X does not equal $5. X equals the number of $5 coins. Y is the number of $10 coins. And Z is your number of $20 coins. That's quick key that you realize those are the number of coins. Okay, so we need to tear this apart. We need 3 pieces of information. I believe the key factors start with the words, customers are told the following things. There are 250 coins. Okay, so what's an obvious equation? Yes. X plus Y plus Z must equal 250. You total up your coins, you got 250 coins. Okay, second one looks not too bad also. We know it's worth $1,875. So how do you figure out how much it's worth? Well, if there are X $5 coins, take them times $5. That's the amount of money you got in $5 coins. So $10 coins and $20 coins. Also, not rocket science to set that one up. Okay, it's the third one that will cause all kinds of issues. Sounds pretty sweet. There are also 7 times as many $5 gold pieces as $20 gold pieces. Okay, now that's the question. How do I write that equation? There are 7 times as many $5 gold pieces as $20 gold pieces. Okay, and 9 times out of 10, students will write down there are 7 times as many $5. So they'll go, okay, I got 7 times the $5, so I got 7x is supposed to equal the $20 gold pieces, which is Z. Okay, ask yourself logically, which one are there more of? Are there more $5 or are there more $20 gold pieces? Well, it says there's 7 times as many $5. There's way more $5. So does it make sense that you're taking 7 times the $5? There's already more $5. There's less of the $20. So it's exactly the reverse. X equals 7 times Z, because Z is the smaller amount, times 7 makes it equal the larger amount. Okay, now in that case, that one's not in particularly nice form. I would like it in standard form with my other 3 equations, so I would need to rewrite, which I'm going to do here. So I'm going to have X, I'm going to get everything all lined up nice and pretty. I've got 5x plus 10y plus 20z equals 1875, and I've got x minus 7z. And I'm going to actually, I want those lined up, so I'm going to put the minus back here, so I get the z's lined up under each other. But what's it equal? Well, yes, now it equals 0. Okay. In this particular problem, there is a huge thing to do that would be smart. Smart, 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 smart here. Okay, remember, we're out to make, first of all, we try to eliminate down and get a two-variable equation. We've already got, the bottom equation already has y missing. You're already got one eliminated. So your first thing is to pair equations 1 and 2 and eliminate y again. It's already gone once, why wouldn't we want it to stay gone? So if I do that, I'm pairing equations 1 and 2, and I want to eliminate y's. So to eliminate y's, I would need to take the top equation times negative 10. So I'm going to have negative 10x, negative 10y, negative 10z equals negative 2500. Copying down the second equation, 5x plus 10y plus 20z equals 1875. I can then add down, have negative 5x, y's are gone, z's would have positive 10z, and the difference there would be 625. Excuse me, but what mistake did I make? Yep, that should be negative 625. Okay, now, if you're still wondering why would I do that? Well, now I have two equations that have two variables in them. So now this is easy. I'm going up here to step 2. I already have an equation which has x minus 7z equals 0. Now I have negative 5x plus 10z equals negative 625. I wonder if I could do elimination on this one. Looks pretty simple, so hey, let's take the top equation times 5 and eliminate x's. So that's going to give me 5x minus 35z equals 0. And then, of course, negative 5x plus 10z equals negative 625. Add down, 5x's cancel. And I have negative 25z equals negative 625. Well, how's about that? Divide that over. Z equals 25. So we now know there are 25 $20 gold coins. From here on out, it's just subbing back in to get the rest of our answers. I need to sub into a two-variable equation. So I am going to go with step 3. And just label it as sub in values and find remaining variables. And it looks to me like the x minus 7z equals 0 equation would be really easy. So I'm going x minus 7 times z equals 0. Well, 7 times 25 is 175, so x equals 175. And remember, it was supposed to be 7 times as large as, so if there's 25 $20 pieces, there's 7 times as many, or 175 $5 pieces. And then last but not least, I need to sub in again, and I have to go into an equation. I have x and z, so I need to go into an equation where I can get y, which means I need to go back to one of the original equations. Ooh, x plus y plus z equals 250. That's pretty sweet. So if I do that, I'll write that out so you can see it, except that's in the wrong color. Let's not do that. That'll mess this up. So I'm using x plus y plus z equals 250. I already know X is 175, and I know Z is 25. So, I believe 175 and 25 add up to 200, so if I subtract 200 to the other side, I find out that Y is 50. So finally, spell out your answer. What did you find out as a result in this thing? Well, how many $5 coins on there? That was X. So there are 175 $5 gold pieces. Y was the number of $10 pieces, so there are 50 $10 gold pieces. And Z, which turned out to be 25, there are 25 $20 gold pieces. And you have reached your solution. Too bad we can't find a bank to do that, because hey, we can solve the system equation really fast, give them the correct answer, and win the $1,875. Wouldn't that be great? Okay, so once again, be sure you realize that if you are working with 3 variables, you need 3 equations. But it's common sense. Stop and think about what you're doing, and whatever it takes, define what your variables represent. That is mission critical. Good luck.